I would like to thank the amazing second grade team of teachers at PSD Virtual. You've been fantastic to work with. We had a lot of fun doing the handouts for those who came by. So if you did that, thank you very much. We hope folks did get stuff in the mail. I will say I did get one returned envelope because it had some issues, but we will get you your glasses, I promise. Anybody else, if you do not receive your glasses by next week, please let us know and we'll figure out how to get those to you. Well, we are the Little Shop of Physics. We do lots of awesome and fun things. And one of the things we love to do is show you how you could do science. And when you get your glasses, you can explore more. We encourage you to share what you've learned from the parts that we send you. And today we're going to be talking about the rainbow and beyond. And I guess I just jumped right in and I didn't really introduce myself. My name is Heather Michalak, and we're gonna have everybody introduce themselves and say what they would want to do when they grow up. And I would say, when I grew up and I graduated, I never knew I wanted this job where I get to play and have fun with everybody. So that's it. And my favorite flavor of ice cream is mint chocolate chip. So there we go. So today we're going to talk about the rainbow and beyond. And I have a quick demo to show you all. So I have a red and a green balloon. And what I'm going to do is I'm going to tuck my red balloon inside my green balloon. Oh, goodness gracious. It really doesn't want to go in there. Making it go. Making it do science. And then I've got a balloon pump. And I'm going to inflate my balloon. Oh, goodness, almost there. Okay, get it nice and full. And because this is really hard to tie, I'm just going to clamp it off with this handy dandy little clamp I have. And I'm going to take my balloon, and I'm going to set it down over here on this chair. And so I've got my red balloon inside my green balloon. And let me make sure I got my camera on it. And what I have here is literally a lightsaber. So this is my green laser. I use it for astronomy. And I'm just going to point my green laser right at my balloon. And hopefully, if I don't jiggle too much, oh, nothing's happening. Gotta love science. We're gonna try this out again. And I think what it is I need to blow up the balloon a little bit more.
Does anyone have any guesses of what they think is going to happen when Heather points a laser at the balloon?
Ooh, what are we seeing? Go ahead and write it in the chat. We can see you. And I might do this. I'm going to be brave. This is going to be scary. I'm just going to hold these things. Yes, no? Maybe right there. Well, shucks. Huh. Okay. Well, I'll say this. We'll come back and do the demo. I'll figure out how it works. But leading into this, so hopefully you can see this later, but Nina is going to show you a little bit about the rainbow and what your rainbow glasses do.
Hi, second grade. So my name's Nina. I am a senior at CSU and I'm actually about to graduate. And so when I graduate, I'm hoping to go off to medical school to become a doctor. That's what I would like to do after school. And my favorite flavor of ice cream is also mint and chocolate chip. I think Heather copied me. But so you all either have or will be getting rainbow glasses. And I have cut mine up because I'm going to put it over my camera so that we're able to see together what the rainbow glasses will do. But basically, if we took a microscope and zoomed in on this lens on your rainbow glasses, it would look like a screen door. There's just like a bunch of little tiny microscopic holes in this lens. And what it does is it takes light and it breaks it up all into all of its little pieces. So white light is actually made up of every single color in the rainbow. So when you put grab some tape. When you put on your rainbow glasses, you'll notice you see the rainbow. And that's because it's taking the white light through your lens and it's breaking it up into the different colors. There we go. So I have a light right here behind me. Let's turn it on. There we go. And you can see the rainbow shooting out from it. It goes all the way from red all the way to purple. I'm going to turn off the light so you can see a little better. Now, a really cool thing about colors is that some colors absorb other colors while other colors are reflected. So I have different colors of cups here that are kind of hard to see in the dark. This one's purple. I've got every color in the rainbow color of cup. And this is just a double-walled cup that we filled with water and food coloring to make different colors. And so what I'm going to do is place these cups over this light, and it'll change what colors you can see through your glasses. And it'll change based on what color each color cup absorbs. So let's have some guesses. It might be a random guess at the beginning, but we'll start to learn what colors absorb the other colors as we go. But we're gonna start with red. So I want everyone to type in the chat, when I put this red cup over the light, what color do you think will be absorbed by the red cup? Go ahead and put your guesses into the chat. I see someone says pink.
Ooh, somebody said
Yellow.
red.
Ooh. Red, yellow, pink. We got all kinds of colors. Red seems to be the popular choice. Someone says blue. Those are good guesses. White. Red, red, red. Okay, so we're gonna take this red cup. This cup looks red, and we're gonna place it over this light. And go ahead and just type in the chat and just let me know what you see, okay? So we see that when I place the cup over the light, all you can really see is red and yellow, right? It's a lot of red and yellow. However, because you can still see those colors, because they didn't disappear, that means red does not absorb red. So every color that disappears is actually the ones that it is absorbing. So when I place this red cup over the light, you no longer see green. The green, and there's a little bit of blue, but mostly the green disappears. You can't see the green anymore. So that means the color red actually absorbs the color green. So what if I take the green cup now? Let's put answers in the chat. What color do you think will disappear when I put the green cup over the light? Blue, red, white, blue.
Ooh, I see yellow and red.
Yeah, these are really good guesses. Well, how about we find out? All right. So we're going to put the green cup over. Let's see what disappears.
What?
Ooh. So it looks like we can see the red and the yellow fully disappear. So that means this green is acting kind of like a sponge, and it's soaking up all of that red color. It's absorbing it. but it's not soaking up any of the green or the blue colors. So let's go through a couple more. What about, let's do a tricky one. What about yellow? What color is going to disappear when I put the yellow cup over? Orange. Blue, red and, oh, blue, red and green.
Blue, gosh, yeah, blue and red is what I'm seeing.
I see some people saying we're going to be left with only yellow and green. That's a good guess too. These are great guesses. All right, let's find out. Yellow cup going on. And look at that. The blue and the purple basically completely disappear.
You mean yellow is a blue blocker?
Yes. That's right there. Yep. And I don't know if anyone has heard of the blue blocker glasses, but they'll typically have a yellow tint on them because yellow absorbs blue color. So I'll do one more. Purple. Purple's a pretty weird one. This was one of my favorites. So one more time in the chat, what color do you think purple will absorb? Green, red, blue. All right, here we go. Let's see.
Oh.
So purple, this purple is kind of interesting. It has two bands of color that it blocks out, and it's mostly like a yellowy orange color. And then a little bit of the red on the edge too. So this color of purple that we've created absorbs that orangey yellow and a little bit of red. Awesome. Turn the light back on.
This is cool. So Nina, can the kiddos do this at home?
Yeah, you just have, you wear your, a lot of you already have your rainbow glasses, but if you just put them on and you have any kind of light, like even your ceiling lights, and then you could just make your own little cups. If you have a cup and you put water and then a little bit of food coloring and you look through it or put it over your light, you'll be able to see that it blocks some of the color through your glasses.
Wow, this is cool. Thank you so much, Nina.
Yeah, no problem.
We could give Nina a round of applause. And for those out there, you could do this. It was a lot of fun. So the next piece of things, so we want to go beyond red in the rainbow. Ooh, and before we go beyond red in the rainbow, I believe I can get my balloon to work. So I blew up my red balloon and my green balloon again. And I've got my laser, and I think I could make this go this time. Let's see. Hopefully, yes, no. See if my laser works. There we go. I'm gonna just set my laser down right here to make it stable. Sometimes science doesn't work, and that can be a little frustrating.
It never works when you want it to. I think that's what I've learned.
Yeah, wow. Here, we'll try one other part of it. So it's cool. So Nina talked about rainbow, and we're getting this to go. So Nina talked about the rainbow, but just beyond red in the rainbow is something we call infrared. And infrared has a huge, like, there's lots and lots of colors of infrared, it turns out. And it looks like my balloon is not going to pop. So we'll move on to the next piece. Reagan is going to tell us about the first part of that infrared part of the rainbow.
Yeah, hi everyone. My name's Reagan. I also want to be a doctor when I graduate, and my favorite flavor of ice cream is chocolate. So, like Heather was mentioning, beyond the rainbow is infrared light, which we can't normally see with our eyes, but we can use special tools like cameras to see near infrared. So, I just so happen to have one of those cameras right here. And what do y'all notice about how things look in this camera? Can you put it in the chat for me? Yeah, so I see a lot of folks saying that they don't see color. That's a very good observation. So as you can see, my hat is purple, and in the camera it looks white. And my hair is black, and in the camera it looks black. But what about my shirt? My shirt is pretty colorful, right? It has lots of different colors. Well, in the infrared light, you can really only see the white letters. I want you to think about why that might be while I show you some more examples of this. So I have this colorful duct tape, and that's how it looks in the infrared camera. Pretty much gray and white. And if you have any guesses to how this works, go ahead and put them in the chat. Now this one's really cool. I have this black box, and you can't see through it, right? You cannot see anything in this black box. Well, when I hold it up to the infrared camera, it looks different. So you can actually see inside the box, and you can see our little friend here, a little circus tiger. You also can't see his clothes in the infrared. Another thing I have here is this special light, and when I turn it on, it doesn't look like it's on, right? You can't really see anything. When I shine it at the camera, you can see it really bright. Super cool, right? So another one, I have a special friend here, this rainbow monkey, and he also looks all white in the infrared. I see some great guesses here. People are saying it's a mirror. Some people are saying it's a night vision camera. So what's actually happening here is certain kinds of colors are absorbed and reflected in infrared light. So as you can see here, my hair is absorbing all the infrared light, and that's why it looks black. And my hat is reflecting all the light, and that's why it looks white.
Does your hair get hot in the sun, Reagan?
Yes, it gets very hot in the sun. So I don't know if your parents have ever told you this, but my dad always used to tell me black attracts the sun. And so not to wear black t-shirts or things like that when I'm going outside. And the reason why is because 30% of the light that the sun lets off is infrared. So, you know how when you go outside and you stand in the sun, you feel really warm? You're actually feeling that infrared light.
That is so cool.
Oh, another thing, I'm wearing some black pants today, and they look white in the infrared. So even though the material is black, they're actually reflecting the infrared light instead of absorbing it.
Wow. This is so amazing. Thank you so much, Reagan. I appreciate that.
Super
Well,
awesome.
so now we've learned about the rainbow, and some colors get absorbed like sponges in the rainbow, and we've seen beyond the rainbow in the near infrared. So just beyond red in the rainbow, near infrared, that's what Reagan was talking about. Now we're going to get 10 times bigger than the near infrared. So if you imagine the color red just beyond that and get 10 times bigger, it's huge. We're going to talk about the far infrared, which happens to be heat. So that's the heat we feel coming off of our bodies and other things. And Connor is going to tell us all about the far infrared.
Hi. Yeah, so I'm Connor. After I graduate, I'm actually going to be a science or math teacher. And my favorite ice cream would have to be chocolate mint chocolate chip. A combination of everyone else's answers. So, if you could just do a show of hands, how many people have seen like thermal cameras in TV or in a movie where you look through a camera and see just a rainbow, but it shows you where hot things are, stuff like that. That's a few of you, yeah.
Wow.
Great. So I actually have one of those right here. So you can see me on the right side here, and then the thermal image of me on the left side there. And you can see how my face is really hot, but then my arms are not as hot. The way this works is I'm actually giving off light based on how hot I am, and the camera sees that light that our eyes can't see, but the special camera can, and then it translates that into colors so that we can understand how hot things are. So if you look at this little graph here, up here, that's the hottest, so the white parts, and then down at the bottom, the blue or black, that's the coldest parts. And it's an adjusting scale, so if I go out of frame, you'll actually see how hot my background is. And then if I come back, I'm still here. And we can do lots of cool things with figuring out how hot things are based on that property. So the hotter things are, the more light they give off, and then in the camera, the brighter they'll show. Can't do that. So right here, I just have a lighter. You'll actually notice that the black bar part right here is pretty cool. So it's not giving off a lot of heat. But if I get it to light, hopefully, there we go. You can see just how hot this fire is. So it's making everything else on me go down in the color spectrum. Ooh. Running out of gas. That's okay. I have a slightly bigger torch I can use. This is very hot. But hopefully you can just barely see that little flame, a big flame. It keeps giving off heat, even when you can't see the flame. But it's a very, there we go, very hot flame. So it's very bright. Another cool thing we can look at is hair dryers. This is probably going to be loud, but
Wait a minute, Connor, when you did the flame, I could see stuff other than the flame, but the hair dryer, I'm not seeing the hot air.
no, if you can, You can see the hot part of the hair dryer, this end bit. Don't touch it. But you can't actually see the hot air coming out. You can see when it hits me. You can see it warming my hair up. But you don't actually see the hot air moving. So the hot air is not giving off any of that far infrared light that we see. But the metal part is, because it's very hot.
So you mean that there's stuff in the air that absorbs that carbon dioxide that's coming off the propane torch?
Yep.
Wow.
Now if I can light this candle, hopefully. You can see the smoke rising much higher than the actual flame.
Wow.
I see a little trail of blue above the flame.
Let's see if I can get all the way out of frame.
So this seems like good evidence for when something doesn't look hot, but your parents tell you not to touch it.
It can still be very hot.
That's a really good point. It's giving off. So is that absorbing? So there's stuff in the air that's absorbing that far infrared and then giving it off again?
Yes. So there's a bunch of different molecules, but carbon dioxide is probably the one you know best, or maybe methane, which comes from like cow farts. Those molecules tend to absorb a lot of heat and then emit that far infrared light back out. So if you have a lot of it, it will absorb a lot and then emit a lot more. But there's also some really cool things we can do with glass to block infrared light.
What?
So if you look at the picture of me, you can see me. This glass right here isn't blocking far or visible light, but it is blocking the far infrared. Same with this fish tank.
Yeah, Miss Cup has a good point. She says like windows in our house.
Exactly. One of the ways we've designed windows nowadays is so that they don't let heat out. They're very thermally insulated. So a lot of that radiation that you like emit, because everything that's hot emits light. See if I can get this just right. If the thermal camera will go. You should be able to see a reflection of my face in my hand in that glass.
Wow.
Or a reflection of the butane torch.
Wow. So
The propane
we
torch.
saw Nina talk about like the rainbow glasses and light we can see, but this camera is seeing a different kind of light. It's just light. Is that what it is?
Exactly. It's just light that technically has lower energy, which means it's stretched out more. So the light we see is very small and wiggles very fast. And the light that this cool camera is seeing wiggles a lot slower and we can't see it. So our eyes aren't built for that.
This is good. And I'd say, so now let's wrap it up really quick. And I realized I didn't ask for a round of applause after Reagan. So for Reagan and Connor, round of applause. Yay. Woo! Okay, so PSD virtual second graders. I'm going to give it a shot again to do the laser. So we'll see if it works this time. And this time I'm actually going to set it down so that it's just concentrated right on there.
While we're waiting for this to work, why doesn't everyone tell us their favorite color in the chat?
Ooh. I think after today, I'm going to say near infrared is my favorite color.
Ultraviolet.
We'll just let that go.
It turned off.
Oh, laser. There we go. Yes, no?
There we go.
There we go. And while we're waiting for that to go, good news, we're going to do another assembly for you all on May 6th, and we want your questions. So what? Whoa! Whoa! Wow, that did something I didn't expect. Science! So when I've done this in the past, it's just popped the red balloon in the inside, but it looked like it popped both balloons. Very fun and exciting. So PSD second graders, we would love your questions. So we're going to do another assembly for you on May 6th. Your teachers are going to send out a form to collect all of the questions you have. And we're looking for any questions you may have. It may be about what you saw today, but it could be other things in science. And what we're going to do is pick some of those questions to answer for you on the next assembly. And I think that's all we have for y'all today. If you have other questions about science in general, Little Shop of Physics is where it's at. Adam put our address in there, and you can send us an email if you would like. Ms. Cup, is there anything else that you or any of the other teachers would like to say before we sign off for today?
Well, first and foremost, second graders, let's give a round of applause to all of Little Shop of Physics for such an awesome assembly. I like how they do the quiet clap. You can send reactions. You can send thank yous in the chat. Also, I want to tell you that the form for you to submit questions will be sent out tomorrow. Okay, and not every question will get answered in the assembly, but we'll do our best to answer all the questions that we can. Okay, friend? All right, thank you, Little Shop of Physics, and thank you, second graders, for being such awesome listeners. We'll see you guys again on May 6th. All right, bye.
Bye, everybody.
Bye, everybody.
Bye.
PSD schools rock!